So in this week, week 10, or meeting 10, we will discuss about walls and partitions. It's related to the building envelope, and it is a part of our design manifestation. That's why walls and partitions usually become the expression of your design intentions. So today we will discuss about 6 subtopics. First is about the definition. Even though you know what is the meaning of wall, but I would like to give a broad scope about what we are going to talk about here, and then anatomy about walls and partitions, and then we are going to take a look on the load distribution as well as materials that is available in our practice, and then followed by the construction process as well as construction drawing. For the first, we are going to discuss about definition. So when we are talking about building structural systems and also its elements, we divided in the previous lecture, we have divided into 2, which is substructure and superstructure. Anything below the ground called substructure, and everything in the upper part of the ground called superstructure. And wall is located in the upper structure, in the superstructure. So it is located up above the ground. And this has become walls, and walls specifically becomes the manifestations of our design, because this is the part that we can look at directly. It's visible directly in front of us. That's why when you try to deliver a design and then you try to draw the elevation, means that you draw the specifically the walls. And the walls can express any meanings, can symbolize anything, so that it's really important for you to express the wall. It's not only related to the shape or the form, but the shape and the form is also affected by the materials itself. That's why when you try to take a look on advanced design idea, for example, the walls can be very difficult to identify, because it's not like very straight forward wall. I mean, like flat surface. It can be curvy surfaces, or it can be solid and void surfaces that's been manifested into the design. So wall becomes the very important part when we are trying to discuss design, specifically related to the structure itself. And also, as you can see here, that wall has the ability to support and distribute the load from the upper part. So that's why we have load-bearing wall and non-load-bearing wall. Even though in this particular course, you will learn only about the simple buildings, like one-story building as your assignment. But I should mention that there is another type of wall, which is load-bearing wall, that has the ability to distribute the loads instead of just becoming the filling of the framework. I think we have mentioned several times that in the superstructure, we have what we call envelope. It's for protecting the indoor environment. And then we have the structure. So the structure helps the envelope to stand as well as distribute and make the form like what we want to. So it define envelope give the protections as well as expression of the design, while the structure itself function as the skeleton and the supporting part of our design. If we take a look back on what we I give you in the previous lecture, I mean, 2 or 3 weeks from today, 2 or 3 weeks ago from today. So, and if we are talking about envelope, there are several parts of, there are several elements that we call envelope. That is roof, exterior walls, windows, and doors. And today we are particularly talking about walls. Even though I mentioned that as an envelope, it's an exterior walls. That's why in this meeting, we will talk about partitions as well, because partitions can be manifested in the shape of walls. But as an envelope, it will be related to the external walls. Walls itself, as I mentioned before, has several functions. First, support the envelope. So if we are talking about the walls, we are talking about the structure inside the walls, then it becomes the supporting element of the envelope, and then also become partitions. It defines rooms, and then the last one is transfer the applied loads to the substructure, because as I mentioned, there is another type of walls which is called load bearing walls, that is that has or hold the ability to transfer the distributed loads from the upper part, such as in this case, if we are talking one-story building, means that the walls will transfer the load from the roof. This is an example of axonometric drawing from a plan. As you can see here, there are two types of walls based on its location. There are exterior walls and also interior walls. In many countries, the exterior walls helps them to provide protection towards the harsh environment. It's quite different actually in Indonesia. So we use walls not for just protections, because sometimes if we remove the wall, it's fine, because we don't have like very harsh environment, even though you consider that our country is really, really hot, but actually you are protecting yourself based from the sun. Is the protection of our home or our building is based on the roof. The walls itself doesn't provide those type of protection. It provides privacy, it defines zoning, but it's not that much like what we will experience in a very extreme country. Like, for example, a country with cold temperature, they need to provide heat inside so that the exterior wall becomes the protection. While in Indonesia, I believe that yes, it can help to provide the protection from the environment, but it's not that significant. That's why when you take a look at drawings in our local practice, the thickness of the wall, the exterior wall, and also the interior wall is almost the same. We use the same materials sometimes, so that there's no big differences. While in countries that need protection from the harsh environment, the changing environment specifically, usually the outer wall will be very thick, or like this one, and then the interior wall will be thinner, because they use it as a partitions. In other practice as well, partitions or interior wall becomes more flexible, so that for the efficiency and effectiveness of the cost, they only build the outer part. So the structure is only in the outer part. So the wall, what we call exterior wall, is built. So, and then the interior wall is given to the inhabitant. So you can choose whether you use 2 or 3 separated room or even open plan. It is a common practice. Even in Indonesia, we usually see that in open plan building like offices. Sometimes you have the freedom to divide the zone or the room based on your expectations, how to use the area. So those are walls based on the location. First is the exterior walls and also the interior wall. If we are talking about walls or exterior walls here in this part, in this outer part, so definitely it separate or connect outdoor and indoor environment. If we are talking about protection, then it will be we are talking about the separation, so that we have those so-called, in the future you will learn about it, like microclimate. So you create an environment inside the area here that is quite different with the outside, and usually it will be more comfortable for you to do the activity inside. Or there is a second thing, which is connect outdoor and indoor environment. If we are talking about walls, it doesn't have to be the separation. It can be a connection. So if we are talking about connections, it can be made from like transparent materials, And then we can see that there is a connection between the built environment and the nature environment. I think you learned the built environment and nature environment in the courses this morning, the introduction to the built environment. So you understand that there is so-called built environment here, the building, and the natural environment. So again, walls doesn't have to be always separate two things, but sometimes it connects when you have a specific type of materials. If you try to take a look on what walls that available in Indonesia, then you can understand that usually in order to achieve like low energy consumption, or maybe what we called something that is using passive system and stuff you will learn in the next semester, you will understand that we are trying to connect the outdoor with the indoor environment. So it doesn't have to be like separation. Next, the exterior walls usually define the building form or the elevations. Again, because this is the outer part or the perimeter of a building, then definitely it will dictate how we try to visualize our idea. So the building shape is actually determined by the walls in the outside, if you are using it, whether it's transparent or not. But this type of elements use is really visible, and it becomes the first thing that acts as an expression from your design. That's why in elevations, you will always draw this instead of what is inside. Even though there is a transparent one, you only draw what is outside the building. So it revolves around the elevations. And sometimes the walls, the exterior walls, become the main load distribution if you use load-bearing walls. And also maybe you use it for lateral forces or vertical lateral load, or maybe vertical load. It becomes the main load distribution. Next, if we are talking about partitions, it's in the opposite of the exterior wall. It's located inside like this, and it definitely becomes a divider of space inside the building. For example, you have an open plan, and then you want to create a space based on your privacy and different type of use. Then you use partitions here or interior walls. That's why I mentioned here that it will provide privacy or zoning, because some people will have this type of activity, specific activity. For example, now I believe that you have your own room, and you are at your own room, or maybe in the study room. So that a partition is needed to define the place, and it provide some type of area so that you have a specific area or room. And usually it is more lightweight than the exterior wall. But if in Indonesia, we use the same type of materials for the exterior walls and also the interior walls, so it might be the same. But there are other types that uses partitions and other materials that I will mention in the next slide, that is use more lightweight materials for the partitions or for the interior walls. If you use a lightweight material, then it will be very flexible if you want to change the building, the space composition or the organization of the rooms inside the building. So that there are some people who prefer these lightweight materials in order to achieve this flexibility in the future. Yes, I think that's all from this like general overview about walls related to the exterior walls and also interior walls. Now we move on to the anatomy of a wall. In this particular course, we are talking about simple building, so that we are using rigid structural frame system where you will use columns and also beams as a framework, and then the wall will be inside here. So this one is this image is called one-way system when you don't have any supporting part here. But if you have supporting part and the ratio is not more than 2, then you can have a two-way system. It doesn't matter. But the configuration of this particular course, we are talking about rigid structure, a wall in the rigid structural frame. If we are having this type of structure, then it looks like this. So you have a framework here, the green one here, it's a Tosca one. So this one is the structure. You have the beam and you have the column, and then you have the wall inside it. So this is what we call the wall in this type of configuration. The loads will be here and will be transferred or distributed throughout here in the column if it's a non-load bearing wall, but it will be transferred. It will be transferred throughout the wall as well if it is a load bearing wall. If you take a look in the next slide, I will give you the explanation about the differences between load bearing wall and non-load bearing wall, because in real life it looks like the same, but there is a big difference on the construction. And even though it looks like the same, it acts different totally because of how we build it. So this is typical of walls that we use in rigid structure system. If we use column and also beam. And this is what it looks like in real life. So you have column here usually, and then you have walls inside it. And then this is the span that usually filled with the wall, with the walls or brick. And actually what we call walls is sometimes people just use it like a combination of the columns and also the beams. So this is like a inside it is a lot called non-load bearing wall, but it depends on how we construct it. It becomes load bearing wall if the construction is quite different. And then inside the walls, we also have openings such as doors and windows. And to prevent the collision of the walls, because it doesn't have, because walls here doesn't have any support system, so you have to provide header like this so that it doesn't drop down to the down part. So this is like a very basic type of buildings that you use, and the down part here is called sleeve, and this type this part called ring bulk. This is what it looks like inside. So basically, to create openings in the middle of wall, so you have to create like a portal like this, or maybe frame, or maybe anything we call like header to provide to prevent the collision of the upper part, because again the wall doesn't have the ability to sustain itself. So that if you create like a span like this, then it will drop down and it will damage the structure. That's why you need the framework here as well to protect your shape or your geometry, so that it doesn't change or have a defection. This is what it looks like if you take a look deeper. If you want to add something stronger to the walls, then you can add anchor here like this. And even for the windows and also doors, you have to put an anchor on that so that it doesn't move around if you try to attach it. This helps you to keep the frame of windows and also doors on place and intact, whether if anything happen. So that it's really important for you to take a look on this one. This is what it looks like in a section, axonometrical section. So usually in common practice, we use clay brick made from clay, and then we have wall finish. And when you take a look down part here, there is called truss ram, in Bahasa called truss ram. Well, I didn't find any what is that called? Any terminology, this one in other practices outside Indonesia, maybe in tropical country, other tropical country there is, but in like a dry or maybe temperate climate, we don't have this one, because actually this particular elements, trasram, is used for preventing the absorption of groundwater from the ground into the walls. If you don't provide this, usually the groundwater will be absorbed into the walls. It creates high humidity inside the walls. And then I think you can see it in your bathroom, for example. That's the easiest way to take a look. When you have a lot of water and the wall absorbed it, you will have a lump, like something bumpy in your walls. And when you poke it, when you poke those lump or bump, then it will break down, and then your pane will be damaged. That's one of the indication that there is a high concentration of water inside your walls. So that's why we try to use trasram alongside the walls, specifically in the area, particularly in the area where the water or possibly used for wet areas such as kitchen or maybe washing area as well as bathroom. So those are trasram. But other than that, I don't think that I haven't seen this type of configuration in other part of practice. And then you have also it directly connected with ceramic tile, which will be explained maybe in next week. And then it's located on top of slough and so on. So you have learned about the substructure. Now we are going to talk about the walls only. So again, the anatomy is really simple. You have the filler. The filler is made from can be from bricks or whatever. It can be from wood. And then also you have the finish of the wall finish and also trasram if it's needed. In other part of the world, you also have another layer such as insulation and also cavity. Cavity is a gap between a wall. So you have wait a minute. So you have another type of things inside. For example, like this, there is a gap here, and then you add another layer of frame to hold the insulation. But it is because in a cold area or colder country, they need to keep the heat inside. While in Indonesia, we don't have that. So that their walls outside Indonesia is quite thick. It's very different with us, and needs something called air tightness. So it must have those type of values so that the heat doesn't go out. That's why when you try to take a look wall and then try to compare in the future, maybe you do an exchange in colder country, then you need to take a look on the local practice, because walls is quite different and there are a lot of variations between Indonesia and also other country. So you need to take a look on that. Next we wait. I lost my arrow. This one. Okay, so after we are talking about the anatomy like this, now we need to take a look deeper on those what is actually happening in the walls. So after you have the bricks will be attached by a plaster made from cement and also sand. I will explain it in the next slide. It will be covered by plaster as a finishing, so that it has the same or flat surface, so that you can add your maybe paintings or maybe another type of materials that you want to use, like ceramic tile or and any other type, but you can use any type of expression towards the wall. If you want to look very neat, then you can cover it with plaster and then put a coating or finish. Or maybe you want to look rough, just add plaster and then you can go with it. So it's based on if we're talking about plaster and coating or finish, it's related to the expression of the wall. But it's always been there and it will be always drawn in the construction in drawings. Another type of wall I mentioned in the previous slide is partitions. And it is a lightweight partitions, usually made from GRC board. This is the flexible one instead of walls created from brick, because basically all the materials used here is very lightweight. I don't know whether you have experienced this before or not, but this type of wall, you can identify it by just knocking it. If you find any sound like emptiness inside, then it is definitely a partitions wall, like using GRC board or gypsum. And if it's not like having those type of sound, so it is made from a solid material. And this one is because when it's finished, you cannot distinguish with whether it's using brick or GRC board, because the paintings will change everything and can be the look can be the same. So that's how you take a look on what is whether that's a partitions that is removable or not. If you use brick, then it's not removable. I mean, not removable is not yes, it is removable, but you need to bulldoze them or to demolish it with a heavy tools. But for these type of walls or partitions, it's very lightweight. So maybe if you just push it and then you are not being careful with it, it can damage. But it's not that easy damage. But I think the strength is lower than what we are using if what we can get from the bricks. Basically, how to identify that is also coming from, we use what so-called metal here, metal stud, and then it becomes the frame, because it's impossible to just add GRC board directly to divide the space. So you have the framing first and then covered it by the GRC board. And then this is what it looks like in section. You can also add additional layers of acoustic insulation inside because it's empty. Because usually the disadvantages of this partition, even though it's very flexible, is the soundproofing. Sometimes you can hear what your neighbors talk or what your family members talk in the other side of the room, because it's very thin. While if you are using a solid materials to create a partitions, then the sound will be majorly absorbed, but this one is not. So that some people will use sound insulation inside this gap. It helps to provide a soundproof area so that you cannot hear what they are talking about in the other side of the room. Now we are moving on to the load distribution. So again, I previously mentioned that we are using the rigid frame. So we are using basically frame. The main load distribution is on the column and also beam. But here I show you there is called the load bearing wall, like this. Means that the wall helps the distribution of load into the down part, which is the substructure. So there are the internal load, which is coming from the weight of the structure that must be considered, and also the other part of the structure, which is the roof, if you're talking about the wall. So if you're talking about this load bearing wall and also non-load bearing wall, means that the non-load bearing wall will not distribute those type of loads from the upper part. It just have to sustain itself, and then its weight will be added for another load in the buildings. So I mentioned previously that actually all the loads is added throughout the elements in a vertical arrangement. For example, if we are talking about maybe this is a 3-story or 2-story building with 1 basement. So all the loads will be added more and more and more. It will be stacked until the biggest part is in the substructure like this. So in the substructure, you have roof plus 2 walls plus 2 floors and foundation wall load here. That's why wall itself, we have to think about the walls, whether it is becoming the load bearing wall or non-load bearing wall. Because if it's non-load bearing wall, we have to consider the materials, whether it is lightweight or heavy. And then if it is load bearing wall, then how can we use any materials to help them distribute the loads. This is what it looks like actually inside the particular wall, because like this one side view, because if you try to take a look on this image, you can only imagine about the column and also the beams. But this one here, you can see the header and also the stud. The stud is here. So anything from roof plus wall and also floor above, if we are using 2-story building, but in this type, we are only using 1-story building. So roof coming down here to the ring bulk in our case, and then there is a header because we have openings here, and then it will be distributed down here, and then we'll be give any reaction towards it. I will give you a very simple explanation. This is what it looks like. Actually, you understand this, but we have to remove the slab. So there is what so-called load, like vertical load from top, which is the roof in our case, and then it will be distributed along the beam here, or what we called ring bulk. And then from the beam, it will be distributed to column and then goes to the footings. What it looks like is like this. If non-load bearing wall, it will be going to the part where the structure is there, like this. So it will just distribute it in 2 areas, here and here, while the load bearing wall will be the load will be distributed to all parts of the wall itself. The look of this type of wall is similar, so that you have to understand the difference is based on the construction. That's why in a glance, if you try to take a look at finished one, like a finished structure or a building structure, you cannot distinguish directly whether it is a load bearing wall or non-load bearing wall unless you know the construction process. Because if you're using beam and column, it can be very similar. This is what it looks like when you are talking about walls. If it is a point, then it will be distributed like this, the distribution of load. And you have to consider that there is another type of load. It's not only about vertical load that's coming from the upper part, but it also coming from the lateral one, which is called the wind load. That also affect will affect the wall itself. So there is this is what it looks like if it is a lateral load. This is the detailed how the vertical loads is distributed throughout the header. So as you can see here, there is the vertical loads from the upper part, which is roof for this case, and then it will be transferred throughout the stud. Here, this is called the load bearing wall because it uses a very small spaced stud, so that the stud will help to distribute the load. And when it comes to this part, because this is the void part, so it will be distributed like this and goes down like this, so that there is no load here and it will be safe for you to use it as an opening. That's why you need what we call header or balok latei in Bahasa to prevent to distribute the load from the upper part so that it doesn't just directly go down, because if it goes down directly in a higher buildings, it will cause damage or collapse in this part. Now we are talking about materials. So the materials available in our country are varied, and I think the common one, the easiest one that you find is clay brick. But even though now clay brick is a little bit more expensive and hard to find a high quality one, but this is the first thing that you can learn from the image in Google. So this is the most common one, what we call clay brick or bata merah, because it's made from clay and then goes to combustion process, and it will be like this. Well, actually, if you are trying to take a look on real clay brick, it will be not like very precise like this. Specifically in Indonesia, the brick will have a lot of damage here, here, and here, and you need to find the best one to use in your building. Again, if you want to use clay brick, you have to check whether it has crack or defection. Defection can be like a very smooth crack inside, or maybe the edge is not sharp anymore, or maybe there is a lump because of gravel or any type of other materials, because it's made from clay. And you have to consider that it must be uniform in size with sharp corner and flat edge, the sharpest one. Even though it's hard for you to find the sharp, like really accurately sharp corner or flat edge in a common brick. And then the standard size is this. Usually it varies around this size. Depends on the area who made the area or the place it is made, such as East Java or Central Java. There will be differences throughout the sizing. Even each this, I don't know what is this, not district, I think like each kabupaten is have different type of sizing, and you have to take a look on that. But just take a look on what is available in your local area. But the size is almost the same. Actually, the difference is not that much, but this is what it looks like. So the length could be around 240 until 230 millimeters, and the width is around 110 until 115, and the thickness, T is the thickness, is around 520 until 500 millimeters. The advantages of using clay brick is it's definitely able to reduce the heat transfer from outdoor to indoor. Specifically in Indonesia, we have a very high solar radiations, so that when you go out at maybe, unless you are living in Bandung, because Bandung or maybe Malang is a little bit colder. But if you are living in Surabaya, Sidoarjo, Gresik, and maybe Jakarta as well, it's quite hot outside because of the high solar radiation. And clay brick helps to reduce the heat from outside, so it becomes cooler inside your house. And it is commonly known by all craftsmen. We are not using engineer in our building process. We are using craftsmen most of the time. I didn't see there is any kind of certification for the craftsman. Craftsman means tukang. So it is really commonly known and easy to apply. So, and it is available widely actually, even though nowadays it becomes very rare to use this one. But it has disadvantages, such as require longer time to dry, because it's made from clay. Even though it's created by a process of combustion, it still has a high amount of water. And usually, if you want to stick this brick or clay brick, before you attach it with the plaster, you have to soak it with water for several hours. It helps to stick with, it helps to attach with the plaster, as well as adding more water inside the material. That's why it needs time. It needs longer time to dry, and usually the construction will take longer time if you are using red brick. Sorry, not red brick, clay brick. And there's a high possibility of crack and break into pieces if you have ever experienced holding on a brick like a clay brick. You notice that it's actually really fragile if you drop it, like for example, unfortunately you broke it at some point, then it will break apart. So it's very fragile. These are what it looks like and how it behaves. So there is there is an advantages and also several disadvantages. There is type of arrangement that is available, that commonly used in local practice, called half brick or one brick. So the half brick is actually like this. So you put it, so the brick is laid based on the lengthwise. So use it like this. And then this has become the thickness, the width become the thickness of the wall. And it's usually used in our practice. And usually the plaster to attach each bricks is using a composition of 1 cement and 2 sand. That's why it's called half brick. So this is what it is also because it is arranged like this. So this is what we call half brick. That's why the thickness is around 150 until 200 millimeters. It's just based on this. So the thickness of the wall is based on this one. While the one brick is, on the other hand, using this part as the length as a thickness of the wall, so that you can see that it is become thicker. I think you can see it in a colonial buildings. They use this type of composition because colonial building is actually adopting the building from abroad. So people abroad using very thick material for creating the exterior wall so that they can protect themselves from the outer environment. That's why they build it very thick. So, but it needs more materials than the previous one like this. And in Indonesia, we don't need to create this type of protection. So that nowadays we don't use this part of this type of arrangement anymore. It is rare for practitioner or craftsman to use this one because it takes it needs or requires a lot of bricks to work with. Another materials that is commonly used for walls is called concrete brick or batako. It's like this. I hope that you have seen this before. And it's mixture of sand and concrete because it's called concrete brick. And there is hole inside it. So it's not like very solid like the clay brick. And the hole sometimes can be added for reinforcement. So that if you need like a reinforcement, like the wire mesh, you can put it inside so that it doesn't move or easily to demolish. And the standard size is varied. Actually, this is the standard one, but it's almost the same with the clay brick. But you can find a lot of type of concrete brick outside in the Google. And then the advantages is it comes with a bigger size like this. It's very big, so that you need less plaster or you need less materials to attach each other compared to the brick, which is smaller. So you need more cement and also sand. But this one is not because it has a very big module and does not need plaster for finishing if you put it like very neatly. I mean, if you are taking a look at this image, this one, because the clay brick sometimes doesn't have a very uniform shape. Sometimes you have some surface that is more protruding than the other part. So that you have, if you want to create a very smooth type of surface, then you have to put a lot of plaster on it so that you can create this flat surface. While for this type of concrete brick, usually because it is made in In a factory, the surface is quite flat, but if you put it very neatly, then it will become directly flat. So you don't have to put a lot of plaster on it to create a flat surface for your walls. And also it has a high resistance toward water absorbance. It doesn't need those type of soaking process, but it is the disadvantages is easy to create hole due to the void material. So it's easily to create. I mean, it's not that easy. You mean if you poke it and then it becomes hole? No, but compared to the solid materials, it is easy to create holes for in a concrete brick. This is what it looks like in the market. So there is this type of bricks, this type of concrete brick. Even you have a solid one, and there is other part which is the endings is also different. Can be flat, can be like this, and this is how you arrange it. It's almost the same like the brick, how you put it, but I think there is no one brick arrangement on this type of concrete. And then this is how you cut it, because sometimes when you have leftover in this in the area in the wall area, so you need to cut it. So you have to use a specific type of tools, because if compared to the brick that is clay brick that is easily to be break down into part, this is not that easy. You have to use another type of tools, stronger tools to cut it, because it's created from concrete. While for clay brick, you just need to break it with maybe your hand. If your hand strong enough, then you can break it directly. Next is the popular one nowadays. It becomes very popular, called lightweight brick or pataringan. It's really lightweight and have a very soft and very uniform material. Usually comes in white color. It's made from quartz sand, cement, gypsum, water, and aluminum paste. So I don't know whether you have seen this, but I think it's become popular because it's very easy to apply and the high uniformity, so that you don't have to waste a lot of plaster and so on. So the advantages is because of the high uniformity, you have an easy way to create a neat wall. I mean, the surface will be always flat, like easily flat if you use this type of materials. And it also lightweight, so that it reduces the gravitational load, so that your building building load is not added that much compared to other type of materials. But the disadvantage of this one is need special plaster made from sand, silica, sand, and cement. So it doesn't use the same plaster as the concrete brick or the clay brick. It used different type of attachment, so that sometimes not all craftsmen able to do it. For example, in a rural area, but in a bigger city, I think almost all craftsmen able to use this type of material. But if you consider, if you compare between light brick with clay brick, I mean, clay brick is most commonly known by all craftsmen from all area, while this one is popular but usually used in a big city because it dries very quickly. You don't take it will not take it needs shorter time to construct a building with this one, because it dries very quickly and you can move on to the next part easily. While for the clay brick, you have to wait for longer time to make the wall dry before you move on to the next step. So this is what it looks like. Well, basically it's almost the same like other bricks, but as you can see here, the size is bigger, and because it's very solid, like a concrete brick, you have to use certain tools to cut it into pieces if you need some adjustment. But because of the uniformity, you can use this type of tools to check whether it's flat or not. And it's almost the same. First, you have this type of thread to help you as a guidance to make a very straight line, and then add adhesive plaster first, and then directly attach the block on top of the adhesive, and then followed by another block, and another block. You have to control the flatness of the surface so that you don't have to put a lot of plaster on it, and it becomes very neat if you take a look on that. Other commonly used materials for walls can be, for example, partitions is GRC board. This is what I mean by GRC board in the previous section. So it looks like this. If you are talking about gypsum, then maybe it's in a white color, but this one is a GRC one. It's mixed between gypsum, cement, and also like a fiber. So when it breaks down, there is something like fiber things coming outside the materials, but it comes in a uniform shapes, and it's very lightweight. It can be used as a ceiling as well, so sometimes it's almost the same, but this one is for the partitions. As you can see here, there is this type of frame, and then it will be covered by the materials. Another type of materials used for walls is wood, specifically in vernacular architecture or traditional building. You will use wood because it's very lightweight and easy to find back then, but nowadays it's harder to find because there are more strict rules on the use of woods, so that it's available. So this is the other used materials for walls. Now we move on to the exercise. So in 5 minutes, I think there are a lot of materials outside what I have explained as a walls. Specifically, if we are talking about the advancement of technology, you need to find those type of material. I need you to find other materials for wall. You can search it in a Google and try to explain the characteristic of the materials. Just put it in your notes. Don't submit it yet. I will ask you to submit at the end of the lecture. So try to find another type of materials for wall that is available, that is used. Try to put the characteristics of that wall. You can add any additional contextual information, such as used in what buildings, and then where it is located. So you try to search another type of materials for wall in that. So I will give you 5 minutes. You can open Google's. I will stop here, and then you can see my, wait a minute. You can see my timer. So try to find it on 5 minutes. And then after 5 minutes, I will continue on the lecture to the next explanation. So 5 minutes start from now. Okay, I think the time is up. Now let's go back to the lecture. I think you need to stop working. Hope that you stop working. Um, let's go back to the next topic, which is the construction process of wall. This is where you can identify uh, whether a wall can be called a load-bearing wall or non-load-bearing wall. So as a general overview, you have this type of arrangement for the wall. So you on top of footings, you have sleeve here, and then you have columns here, and then this is ring bolt, this is header to hold on the openings, and then this is the wall as a part, as an integral part. And now, if we are talking about walls, there are two type of works that's related to it. First is called brickwork. So wall filling process means that how you assemble what is it materials for the walls, and also the plaster work, and it's related to the wall finishing process. And this is the differences between non-load bearing wall and also load bearing wall. During the construction, if non-load bearing wall, the first thing to build is the framework, which is the columns and also beams. That's why it is finished first like this, and then followed by this is the base, and then followed by the walls. So the wall acts as the filler. It's filling the empty space between the framework. So that's why it acts as a non-load bearing wall, because the wall doesn't have any ability to distribute any type of loads from the upper part, and it doesn't have this ability. This type of wall is easily to be modified. So in the future, if you want to create openings in it, you just can destroy it or demolish it and then made it as a big opening like this. This is what we call non-load bearing wall. Compared to it is load bearing wall, which is like this. So the first thing to build is, of course, the sleeve is finished. Just try to assume it as a uh, as a as a sleeve, and then the second part is try to arrange the brick first or the wall first. Usually, it must be a masonry type of material such as brick, so that you just put it here inside. And while, as you can see here, the column is not finished, you just put the reinforcement in it. And then when at a certain height, usually maybe a meters from this surface, you start to add reinforcement. You start to add the concrete into the reinforcement like this, so that it also add another reinforcement inside here, like an anchor here, so that it becomes one. So it adds more strength towards the building, and so that's why you build it little by little, and also add the reinforcement during the construction process. And then it follows, finish it like this, and then put another type of another addition for the concrete, and then finish it with the beam like this. It has the same type of understanding that you are using a rigid frame, which is the um column and also beams, but because of the differences on the building construction, it acts as a load bearing wall, while this one non-load bearing wall. That's why some people will hard to find this in distinguishing this type of construction process. That's why when you try to define a non-load bearing wall and also load bearing wall, you have to understand the construction process. The differences is on there. So first, if you are trying to non-load bearing wall, then the column and also beams will be available first, and then followed by the filling of the brick, while the load bearing wall will be you have to provide the reinforcement of the column first, and then followed by the brick, and then it builds up a long way. So together with the brick. And this type of load bearing wall is usually used for it must be used for us in Indonesia, because we have the possibility of earthquake, and to prevent serious damage on the building. For very simple building, government advised us to use this one, because if we use this one, the possibility of the damage is higher. Imagine that this type of walls, you have a lateral force. It's like the shaking, and then like what I mentioned before, if you got a lateral load here, so that it will collapse, but it does, and it doesn't have any type of holder or maybe anchor. While this one, because you build it alongside building the structure itself, so that it has anchors, and it will stay on place during the earthquake, so it doesn't create serious damage towards the building. That's why our government advised us to use this type of construction process to create the load-bearing wall construction, the load-bearing wall elements, so that we can prevent the collision of a building during the earthquake. Those are the differences between the non-load-bearing wall and load-bearing wall, even though as you can see here, it's almost the same. This one is different because the image is different, but in real life, it looks a lot similar. So you cannot distinguish it. This is what it looks like if we want to try to build the load-bearing wall. If non-load-bearing wall, you have finished the column. So, and then you put the brick directly, but for the load-bearing wall, you create like this, something like this. So there's an anchorage here. This is a reinforcement, like additional reinforcement for your wall, so that it doesn't collapse easily towards the side. And then after finished like this, and then you pour the concrete, and then it will be attached together, and it adds more strength to it. And usually from this part, they say that the anchor should be in the 6 layers of brickwork. In the drawings, you will not see this because it's not like visible, but in the construction process, you need to understand whether it should act as a load-bearing wall or non-load-bearing wall. And this is what it looks like after 1 meters. Then you pour the concrete or the mixture, so that after that it will dry for several times. You leave it for maybe 1 day, and then it will dry, so that it attach each other. The element becomes one, so like the liquid becomes one with the bricks like this, and then follow to the next step until it's fully finished based on the height of the wall. This is another type of construction process, which is we call wall finish. So in the beginning, you will create the mixture made from cement, water, and also the sand. You don't have to, well, it's probably 1 to 2 or 1 to 3 in the ratio, but I don't think that you need to practice on it. Usually the craftsmen understand, but you have to understand the quality of the mixture, so that you make sure that it is a good one. The element can perform well and can fulfill your intentions. And then after you create the mixture, you use it as a plaster. So you arrange the brick, and then add after 24 hours, after it dries, you put plaster on top of this surface. This one helps you to create a similar or flat surface for your wall. You can call it the plaster here in Bahasa, we call it kamprot, something like concrete, rough thing. So it can be an expression, so you can finish it from there. So maybe you want to create an industrialized type of image or rough image, then you finish it during this process, just use this type of plaster and then done. But if you want to clean look, or maybe you have another idea, such as ceramic tile, you just add a ceramic tile on top of it. But if you want to use paint and want to create a flat surface on top of it, you have to put another type of plaster, which is finishing materials called aci in Indonesia. So you put that one, and then after it finished, because it's very smooth, the aci is very smooth, so that you can add paint on it, on top of it, or you can give glue and then also wallpaper on it. So it depends on what you want to express in the walls, either inside or outside. Some part of the wall, such as in bathroom and also kitchen, has another layer which is called the water resistant layer. So you put it after before the painting, and usually it will give protection towards the water, so that it doesn't create fungi, or maybe something like the lump that I mentioned before. So that's why it depends on the location of the wall, whether you need additional type of materials such as waterproofing or not. It depends on the area that you are concerning about the wall. And then this is what it looks like, and how to actually create those plaster. Before applying the plaster, you need to make it wet. So specifically, if you are using clay brick, because when the clay brick is dry, it is really hard to attach the materials, specifically cement, so specifically the adhesive materials such as plaster. So instead of doing that, so to make it quickly, you have to spray it with water like this. When it is on a wet condition, then you add the plaster, and then make it neat using like a long bar, something like that. I will give you the example of how to apply it, and then it creates a flat surface that you are that ready to be used for modification, such as ceramic tiles or maybe paint. On the other hand, if you are talking about partitions, and in this part we are talking about GRC board, there is what so-called the frame inside of the stud. There is the top one, which is located on top of usually it doesn't have to be on top of the ring bulk. It can be just attached to the ceiling, because it doesn't have any function to distribute load, so that it can be attached into the ceiling. That's why this type of wall or partitions can be built even though the building is finished already, and it can be easily moved. And then there is this top track will be attached to the ceiling, while the bottom track will be attached to the floor. And usually it is on top of a floor, the finished floor, or not. It's up to you. And then there's another part which is called stud here to help the frame stand still. And then there is what I call acoustic insulation, if you want to create a soundproof area, because I think my flat when I was a master degree, I have this type of wall, and it doesn't have any insulation, acoustic insulation in it. So when my friend calls their parents until she cried a lot, I can hear it, because the sound is transferring from one area to other area. Even though when I asked her, do you cry? And she answered, no, I actually can hear that she is crying on the other night, because there is no acoustic insulation. So that's why you can choose whether you need acoustic insulation or not. It's not like a must thing, but if you have any concern about privacy, then I believe that it is important and a must thing for you to add acoustic insulation. And then on the outside, you add a gypsum board to act as a finishing, and becomes the wall. As you can see here, the attachment is actually from screw. So you are not allowed to screw it on this part here. So it must be like a little bit down, like maybe 100 millimeters on so or so. It's very technical, but I think you need to see it. And then there is a gap between the screw distance here. So this is the side. So the side will be always shorter than the middle side, and then you put sealant underneath. So because of the nature of the materials, the GRC, that is easily to expand during the heat, during the hot time. So you need to spare a space actually, and then on that space you put sealant so that it doesn't have so it is protected from animals such as cockroaches or dirt. That's the sealant for. And then also you have staggered screw here if you have a joint type of board. So because the board is limited in size, usually 120 to 40 millimeters, as long as I remember, and there is a bigger size if I'm not mistaken, but what I usually use is 120 and 240 millimeters. And then you usually use it if you want to attach one part to another part. You have to use a staggered screw method like this. So this is an overview about how you build the interior wall, which is partitioned from a very lightweight material such as GRC. This is the elements of this type of configuration. So you have like U channel as a track here, and it's upside down like this, so that this part, the bottom part here, is attached to the ceiling. And then for the middle part, you have stud C channel, and then here is the gypsum board, and then this is U channel again. So mostly it is made from a metal or aluminum steel, as long as I remember. And it is very lightweight. So you can, well, even, but you can bring it everywhere actually, because it's very lightweight. So this is what it looks like. And there are several sizing. It depends on the available space for you and the available material in your area. So it's varied a lot. So you can just choose or pick one. Now let's go to an exercise again. I have asked you about the materials that can be used for walls in the previous section. So now think about the wall materials you provide in the previous section. So think whether is it possible to use it as a load-bearing wall or non-load-bearing wall, and why. If you have understand the load-bearing wall and non-load-bearing wall, then you try to analyze whether or not the material you provide can be used as a load-bearing wall or non-load-bearing wall. And then just try to give a short explanation about that. Maybe you can add some drawings if you can. Try to explain about why how it works if it is a load-bearing wall or non-load-bearing wall. So I'll give you 5 minutes. Again, I will show you the timer while work on that. I hope that you can follow it. We'll reset this one and start from now. Okay, I think the time is finished. Now let's move on to the next part of the lecture. I need you to stop working on that exercise. Now, this is the last part, which is called construction drawing. I don't think that it needs more explanation because you have experienced it, you have tried to draw it. But I would like to give an understanding first. So during the drawing, usually this will be the wall will be expressed into two types of drawing style. First is plan. Second is the sections. The plan and section have the same type of expression, while elevation also express walls, but in a different type of expression. If you are talking about section and also plan, usually you will take a look on what inside the walls. So the materials, the layer inside it, you can take a look on that, because section, as you have tried to do in your previous studio, like when you cut the fruit, you understand that section and also plan is actually a cut through of the building, so that you understand how it looks like inside and what's inside. Well, actually, it depends on the scale, but for this particular course, you need to take a look on like a very small scale so that you can take a look on the detail of the walls. That's why you need to take a look on what's the layer inside the walls. So in the plan, what you see is the horizontal cut of a building, so that what you see is the the wall itself with other type of columns. So what columns do you use and how it attach. And then for the sections, you will take a look on the beams, for example, ring bulk, and then header if you are cutting those this area when you are talking about the section. And then also the sleeve and also truss ram if you are using truss ram. So those are what it looks like. So when we take a look on this one is a very simplified construction drawing of walls. So you have understand the substructure. So we are talking about the superstructure, specifically walls here. On top of sleeve, you have truss ram, and usually it's about 20 centimeters above the zero elevation of the floor here. But it can be more if you work with bathroom. It will be more because the water is a lot, so it becomes a wet area. But if it's not like a bathroom or kitchen, then you can use just maybe 20 centimeters from above these type of elevation. And then you have the brick wall, and as you can see here, this is the hedge of the brick wall. So there are other type of hatchings in CAD, but when you are using CAD or maybe even drawings like hand drawing, this is what indicates a brick wall. So this is look like this. I forgot it's ANSI 31 or ANSI 32, as long as I remember in CAD. And then the angle is already like this, so you know that this is a brick wall. Outside the brick wall, you have this type of layer, which is called plaster that I mentioned. This one is for finishing. And then on top of it, usually you have paintings, but for the paint, you don't have to draw it in the section. Just this one already mentioned about indicates wall. And then you have this type of if the wall is really long, for example, this one, because I cannot put like a very full one, I can use like this type of function, like cut it like this, and then give a dimension here. On top of it, we have a ring bulk like this. So if you are create a section through openings such as windows or doors, then you have to adjust this type of beams. header is also like a beam, and it's almost like this, the same type of this, but the size is, I think, almost the same as well with the ring bulk for the one-story building. So on top of the frame window, will be explained in the next meetings. You will add this type before the opening, so that it will hold the wall so that it doesn't collapse down. So those are the how you draw it. I think it's very simple, you know it. And then this is how it looks like, Trasram. So this type of symbol is already standardized, so you must use it. You cannot like change it by your style. Oh, I don't want to use it. So this, when we are talking about constructional drawing, it is a standardized one, so you have to follow certain rules, and it also it so that it will be understood by another person. Because when you draw constructional drawing, it's not only for you, actually, it's for the craftsman, for the engineer, so that they understand where and what is it made for. So this type of drawing must be understood like this. This is what it looks like. I think you have tried to draw it in the previous assignment, and I hope by showing this, you can draw it exactly like this in the next assignment. And for the partitions, well, the partition itself, this is what it looks like from the front part, or maybe it's not the section. So you can take a look that there is a certain type of framing here, which is usually divided by the same equal span. For example, like this. See, so it will be A, depends on the span of the area that you want to build the wall. And then it will be attached with this type of covering, which is the board. And then the joint will be like this, staggered, like I mentioned before. So this is what it looks like when you are trying to draw the partitions. But when you are trying to draw it from the section itself, it's really easy when you try to understand how to build it. For example, I will give you the video about how to build this one if you never ever experienced or meet how to construct this part of wall. So if you have floorings like this, you just draw the hollow here, or maybe you can use U channel, and then also here, for example, so that it's so let's use this one for easy example. Wait a minute, how to erase this one, it's a pen. Oh, why? Okay, so now take a look on this. So for example, this is the this is the ceiling, and this is the floor. So what you do in your section is drawing this part like this, because it is a huge channel like this. There's a top here, and then you have this one here, for example, because it's just like this. And then the board will be here. So it's like a thin layer of what you have seen in the previous image, like this one, like a thin layer like this. But this here, it illustrates the board. So it's not like this one, which has this type of feeling, but this one must be empty, like there is no feeling on it, but you have the stud here. It depends on how you design the stud. So that's how you draw the partitions and the walls. But if the partitions created from the same material like brick, then you can draw the same type of image like this. That's all. So now let's move to another exercise, because it's very simple. I just want you to recall what I have explained before. So wait a minute, arrow. So this, do you see the axonometric drawing here? Can you see it?
Yeah, Bu.
Yes. Okay. Just put a label on it. So the A will be this two arrow. You can write it down in your note as well. Just answer A, B, C, D, E, F, and also G. You can put it a label on it and then answer the question, just like the IELTS test. You just need to put a label on it and then answer this question. What information is important to be illustrated in a construction drawing of walls? So what do you think is the most important information? And then why? Just put it that way. So I will give you 5 minutes to answer this 1, 2, 3 question. First question is labeling the image here. And then second is what information is important to be illustrated in a construction drawing of walls, and then the reason why you should put those information into the drawings. So I will give you 5 minutes. I think I will not leave it behind. So I will use my timer here because you need to take a look on this image. So the 5 minutes starts from now. You can start to work with the exercise. Okay, I think the time is up. That's all from the lecture, and I need you to send me the files of the exercise now in the chat box. So I will wait for maybe 4 minutes. I don't think it needs 4 minutes to upload it. So I need you to send it now in the chat box before I continue to the next explanation about examples on the construction process of the walls. So do you, can you send it? I think I have given you the access to send a file through the chat box. So you can send it in PDF or maybe in JPEG. It's up to you, but I'm waiting for it. So it becomes the attendance record. So just send me your answer here. You have to send me before 10:50. Outside from that, then outside that time, I will not consider it as a record attendance. So again, you have to send it now. Finish or not? Okay, thank you, Fania. 1, 2 from Nadia.
Excuse me, but I put it on my notes alongside with the lecture notes. So I actually have to make it into another G-Docs.
No, it's okay. You can just submit it. Sukma, yeah. I will not judge your note. Don't worry, just submit it. Okay, so around 4-5 per minute. 1, 2, 3, 4, 5. Okay. Sabrina, what type of file is it, Sabrina?
I exported from my Notion book.
What do you use? Is it Markdown or?
It's PDF. It's PDF.
Okay, because it lost the file extension, so I need to check. Oh yeah. Okay. Copy. So I've got 1, 2, 3, 4, 5. Got 5. Where's the other? If you have any problems with the internet connection, just tell me. Or still exporting? Okay. Right.
Sorry, Bu, but the internet is kind of lagging from me.
Pardon?
The internet connection in my house is kind of.
Okay. The easiest way is just capture the screen, Cindy, and then send it. I think it's become smaller. The size will be smaller. So you can, yeah. Okay. So we need, oh, I put. Okay, so we have 1, 2, 3, 4, 5, 6. There are only 6 students who submit the work. 7 with Hisham. Why is it taking longer time to export? Okay, now while waiting for the other to submit their work, you must submit it if you want to be recorded to as attending the class. So you need to submit it through the chat box. I will give you an example of how we construct a wall. check. I don't think you need the sound, so I will not turn on the sound. You can find a lot of videos related to this part on YouTube. Here I will choose, I will give you an example of local practice so that you can understand the context in Indonesia first. And then in the future, if you studied abroad, then you can take a look on their local practice. Usually they have a lot of video as well as and also maybe guidelines about the building construction. So this is what it looks like, how to create a wall. But this particular one use the light brick. I will put the speed on the quickest one. So well, actually you need to use this type of what is that called? Thread. Usually craftsmen will use thread to maintain the height to the same level of each part. And then they use this adhesive and then put it directly on top of it. Again, you don't have to build it by yourself, but understanding the construction process will help you to illustrate it in your constructional drawing. I hope that it's not lagging because I'm using YouTube. I will give you the link after this in the chat box so that you can access it by yourself. This is what it looks like when you are trying to build a load-bearing wall. Because as you can see, the column is not finished yet there, but you can find the reinforcement, and then they try to assemble the brick first. So this is what it looks like. No matter what the material is, such as the concrete block, for example, or clay brick, it's the same like this. So this is what it looks like in the real life. I think that's all from this process. I think it's very simple. You just try to stack your brick, but you put adhesive in between, which is called plaster. And then after that, the second process is the wall finishing. So the wall finishing is here. So when you finish that this is what I mentioned. You have to make the walls wet first. It's just add some adhesive type of condition, and then you add the plaster. Just usually the craftsman will be just throwing it away like this, so it's very rough, what we call kamprot, and then it will be left to about maybe 24 hours to dry, and then add an additional layer so that you can have those type of things that you draw like a very slender line outside your hatch, like the brick hatch. I think it's already the quickest speed, or I will add the speed. So you don't have to. Here, this is what I mentioned. To create a flat surface, you need to have a guideline like that. So you create this type of surface like that, and then fill the rest of it and follow this type of things. This is what it looks like. You can check it by yourself. After this, I will give you the link. See, this is how you create the surface flat. This is what they do. So after this process, sorry, adik, ya sebentar. Sorry. So after this process, you will have a rough but flat plaster surface, and then you add what we call ati. So this one is another layer to finish the walls. So again, you have to create the like a wet condition so that it attach each other. In this part, you have more soft or more flat surface like this to prepare your wall so that it will be ready for paintings and other type of materials. But if you choose using ceramic tile, then you usually doesn't need this type of process or artisan, or make it very smooth like this. So everything should be like this to prepare next coating or finishing for the wall. After this G layer finished, you have to just make it more flat or more soft by doing softer by doing this type of process. It takes longer time than usually imagine, but if you work this one very well, then the finishing of your wall is clean enough. If you don't consider that, it will be like a little bit rough for your walls. So those are how to the process of finishing this the wall finishing. And now it's about the wall partitions that created from the GRC. So again, as you see before I play, it's actually already built, finished like this. So they just attach it on top of the floor. You can do it, or maybe some buildings like for example in the UK, they didn't use ceramic tiles, so they usually use carpets. So under the carpets, it is like a bare it's like a bare slab floor, so that it doesn't need any coatings. So they can move it around, like the partition can be moved around, and then just after finishing the partitions, then you add the carpet. So it depends on the area where you want to build it. So this particular practice is usually in Indonesia when you have already built buildings and then you want to divide it into more spaces. So that's why you need to just attach it on top of that. So let's take a look. So you need to nail it down into the floor like this. So it doesn't look like it will look like regular walls, but it's actually made from the GRC. As you can see, there is this type of framing, and he uses nail and also screw. Again, he will attach the down part here, and then followed by the top part after this. So, oh, wait a minute, a lot bigger. So he creates this one. You don't have to create this one, but you need to understand the process. See, it just attached to the what is that called? The ceilings. So it doesn't have to be structurally like attached. So it just need to attach to another surface. So this one is attached to the ceilings, and he tried to build openings as well. You can also create openings from this type of configuration as well. This is how you create the stud so that it doesn't like it will give support to the board like this. When it's finished, you just attach the board. If you're wondering why the corner doesn't close, because this building uses cornice or something like decorative stuff on the corner, so that they didn't use so he didn't use those like connected part. But the finish is very smooth because you can close it with other type of materials. So again, this is how it looks like, and this is the board. I will continue quickly here. This is how you attach the board using a screw again. And then the finishing is if you try to directly give a paint on it, it definitely will look like there is something like connected, like two boards will be connected into one. So that's why you need another type of plaster like this to close the gap and any holes, so that it will be flat throughout the area. This is how you create wall partitions. So, and see, he tried to close the gap between one board to another board, so that when you try to paint it, everything looks really smooth, and it doesn't look like it is something that is attached each other. So this is what it looks like. I don't. You can check it after that. And then I will check additional. Wait a minute. Cindy and then Sabira. And then Naufal. Okay. So we have. Wait a second. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait a second. There is one student who doesn't submit. Okay, I need to check it for this. So Sabrina there. Sabrina. Oh, Sabrina, it works already. I can open it. So yes. Now file there. So I will check each one of you who doesn't submit the works. Now let's take a look on your answer here. Right, so wait a second, why it's not working? Oh. Wait. There's someone who sent it. Oh, okay. Okay. Okay, so let's take a look on your answer. So first, about the wall materials, there is, what is it? Timbercrete. Timbercrete is almost the same as conventional concrete, which distinguishes from the type of gravel replaced with wood chips. Wood chips, okay. It can be a load-bearing wall because it's easy to work, have a lightweight, waterproof, flexible. Okay. Next we have silicate brick, lime and quartz sand brick. Okay. Structure with white gray application. Okay, environmental high compatibility. Advantages. Oh, it's a long one. Ability of the typical load bearing wall. It has high thermal conductivity. Well, as you can see here, this one is not really explaining why it is capable of load bearing wall and non-load bearing wall. This one is Hisham. What is this Hisham? Pak Batu kapur? Is that what is this Hisham?
Bata kapur.
Oh, bata kapur. All right. Okay. Going to install. Don't need a lot of cement, sand, need a practical column every. Okay. It's a loading bearing wall because I'm not sure. Okay. So next we have what type? Oh, sorry, I will check here. One part, materials, clay brick, and where's
Itu
the
Bu,
answer?
itu Bu, agak di atas dikit.
Where
Iya, yang di
timber?
frame.
Oh, this
Ada
one?
di atas lagi ada load, yang load bearing walls.
Oh, this one. Okay, cavity wall is double wall that's in center. Okay, and then Fari material. Wood material, okay. And then autoclaved, what is that? Fly ash bricks. And then other one. I think this is Sabrina, right?
It's on the material part. The
Oh,
stone.
right. Okay. Yeah. Okay. TRC board. Yeah. Okay. Okay. You mentioned about metal, vinyl, and stone. Load bearing wall, stone wall. Yes. Okay. And then next is Nadia. Common cladding alternatives. Okay, you mentioned about cladding, so it's related to metal, vinyl, and stone, concrete. Okay, plastic. And then the load bearing wall. Where is it? Okay. So next we have this one. Glass. Okay, mycelium. A type of fungus. Oh yeah, mycelium, bamboo, and hay. Yes. So this type of wall, I find that my friend has a research on it. It's amazing. It's very lightweight but very high thermal capacity. So that it's really amazing. Fair rock. Oh, okay. Right. So now let's take a look on this as exercise. Like A, reinforcement, anchor. Which one? Anchor B, right? And then wall. C is wall. D, column. D, column, right? E, sloof, right? Plaster, brickwood, plaster or brickwork. Okay, brick. G, brick. Okay. Oh, why is it closed? So I will take a look on this quickly because I think you understand about this one easily. Yes. Okay. This is the part that you have to answer correctly. What is important to be illustrated in construction drawing wall? Okay. So the hatch to see know what kind of materials to use, the size to know the sizing of each construction element, the section to understand the structure as a whole, the plan to translate the design efficiency. So I need you to take a look on. Oh, this is not finished one. Notation, dimension, clear indication of component, and also hatch. Okay. I think there are a lot of answer here. Right. So let's take a look back on these constructional drawings. So the most important part to draw in section in drawings, constructional drawing of a wall is first exactly showing the materials. You can use hatch as an illustration of section or as illustration of the materials such as this. For example, this is a brick wall, and then it will be different with this type of landfill hedge and also truss ram hedge. So those type of hedge will represent the materiality. And then notation like the dimension is really important for you to put, and where the dimension is put is also important because you need to make clear on the sizing of each element, and then also how you attach those type of type of drawings. For example, this one. Oh, sorry. Oh, where is it? Oh, this one. Make it zoom. There is something that is a little bit funny here. I don't know whether you notice or not. This drawing is a little bit weird if you try to build it or when you try to do it in a real life, because as you can see here, this is the floorings or the slab, and then this is the wall. You have finishing and then added the slab, which is not work like that. Usually the finishing is only end up in the finishing only like this, so that this usually in here. So this is something that you need to take a look on that, so that even though it's very small part of the build of the wall drawings, or the constructional drawings, but you need to understand the how it builds. For example, this one, just imagine you have, if you have this type of drawings, as you have been explained about the building construction process, you try to build the wall after finishing the structure, and then lastly you have to put the floorings. So it is possible to add like finishing here, and then it's the floor slab. So usually it directly attached to those parts, because usually it's related to the structure itself. Again, the connection between each part is really important. You have to understand that, because and sometimes when you try to draw it, you need to question it yourself whether it is correct or not. Usually when I draw something like this and then I try to understand how to build it, when you try to understand how to build it, then you can understand how to illustrate it correctly. So again, I think you all have understand that the most important part of the buildings, the constructional drawing, is the information such as the hatch. So it must be there and show the exact materials, the dimension, as well as the notation. So for example, brick wall, truss frame, or what other materials that you use. I think that's all. If you have any question, you can raise your hand before I explain about the assignment, the next assignment, which is assignment 3. That is actually the continuation of the previous assignment. Well, we are a bit surprised that none of you have contacted us to have a tutorial to revise your work, but I don't know whether it's already a good revision or not. We hope that it's a good revision, but it's a surprise that you haven't been in contact with us for the past week related to the revision of the work. So before we are moving on to the assignment, if you have any question, please raise your hand and then we will discuss about the question that you ask. Is there any question?
Maybe I want to ask a question about the GRC structure. What is the lengthwise of each of the studs?
The lengthwise, the maximum, you mean? Okay.
Between each stud, because I don't see it in the presentation.
Okay, so it depends on the board that you are using, Sukma. So for example, if you're using like one, it's actually must be divided in the same type of length, like the ceilings. Well, I will give you the whiteboard. So there is no like maximum, there is the maximum is depends on the maximum size of the board. Like for example, the available board is 120 to 240, like this. For example, this one is the board. And then when you try to create the stud, try to divide it, for example, into two, like this, the board. You just, the guideline is based on the material that you use for the covering. So the stud will adjust to that. So for example, you have this type of board like this, 120 to 240 means that it must be between, for one board, you will have like two type of stud, three stud consist of two spaces, which is, it's about 60 and 60. But if you try to attach it in the other way around, for example, this one is here like this, you put it like rotated here so that you use it like this. So this is 240 and it is 120. Then you can use a longer one. The stud span will be longer. It depends on the material that you are using, like the GRC size that is available. It can be shorter, so that just understand that if you have like a plan like a surface, and then you will have you need to make it stronger, then you have to provide like at least the side, two sides, and then the middle one. So it depends on the size of the board itself, Sukma. There is no maximum size, because each type of a board will have each type of sizing. So it depends on that, and also your arrangement, whether it's horizontal or vertical. So it depends on the sizing again. And then you have to divide it, for example, like this. You have like maybe 2 meters like this, and then you have to divide it into equal parts so that it's the lateral load, it's only talking about the wind load, which is not big actually, is distributed evenly, so that if you have 2 meters and this is about 250 centimeters, 250 centimeters, you have to cut it down, and you use so like this. So it means that you have to divide it into probably 5 or 4 spaces for distance like this, for span. So if you divide it into 4, means that it is 50 centimeters each, or if you try to divide it into 5, then it will be like 40 centimeters each. So there is no maximum one, but you have to consider the sizing of each material. Is that clear, Sukma?
Yes, Bu. Thank you very much.
Okay. Other question? Okay, while waiting for question, then I will explain about the assignment. Where is it? Where's my assignment? Oh, this one. Sorry. So, I cannot see it. So the assignment is already available in the classroom. You can check it. Well, actually, it's the continuation of the previous assignment, so that you need to have a good revision on the previous assignment so that you can go to the next assignment. So this assignment is, the object is related to the enclosure system, the element and specification of a guard house. I think the location is the same. So in the task consists of identifying and describing the enclosure system, element and finishes required for the building. Basic design is provided. And then the design of the enclosure system, elements and finishes. You have to create a 3D model of the enclosure system as well, including elements and the finishes of the buildings. And then next, you have to provide working drawings for the enclosure system, elements and finishes, usually in details image with a smaller scale. And then provide descriptions for the enclosure system, elements and finishes used in the building. The last one is provide a construction document for the enclosure system, element and finishes of the building. So it will be an individual assignment, and we will give you 3 weeks from now. Again, we would like to encourage you to contact us as soon as possible. So don't wait until the end of the deadline and then you contact us, or I have to ask you to, you should contact me or Pak Ngura as soon as possible. You need to be more initiative on this type of assignment, because again, the learning process is actually be more precise on the tutorial session rather than the lecturing session, because in the lecturing you just get the basic understandings and then the application will be in the tutorial session. That's why you need to have an initiative on this one, unless you want to be left behind. And then all descriptions should be based on credible references and cited on the documents. And each student requires to have at least 2 discussion sessions with their tutor, or we can call it tutorial session. Again, the tutorial session, if you are feeling like, I hope that you can do it together with your friends, because from there you can learn each other and compare each other. It's not like about comparing yourself is better than your friends, but the most important things about the tutorial, to go to tutorial in a group, is learning from each other, so that you can take a look on your friends' work and then try to improve your works if it is not like better than them. So the output is again axonometric drawings of the enclosure system, elements and finishes of the building, and annotations indicating their specifications. Here there is specifications. You need to take a look on the available materials in the Googles or wherever it's that. Maybe you visited a building exhibition, usually in like online one, because they are more specific. And then you want to, oh, I think this is a good type of materials that related to your work. It's okay, no problem. So again, you need to find the specifications. You cannot just put like, I want to use maybe gypsum, and you need to understand the gypsum sizes and then also the thickness, even though you don't have to like put the name of the ingredients of the gypsum, but you need to understand the specifications such as the sizing and also how big the module is. And then a description of the enclosure system, element and finishes of the building. And then the last one is working drawings of the enclosure system, element and finishes of the building. It will be presented in plan, section, and also details. And then at the end of these pages, you need to put list of references. But I hope that you can put, if you use certain products or certain materials that need, for example, explain about specifications and other characteristics, you need to insert the sources inside the inside the drawing so that we can understand what we can see that it is a robust sources or not. So you cannot just say this is because my craftsman said that I can use it. So no, you have to take a look on a specific references, like a believable and robust resources. The format is the same. It's in A3 size paper. And then you have to create building plan, floor plan, and other plan that has been finished in the previous assignment. And then for the building plan here, it's related to the finishing to the building envelope. So you need to take a look on those type of drawings. And then elevation for sites and sections, at least 2 sections. And then floor pattern or type and material specifications in those details, and then ceiling, and then wall, and also doors and windows type. Again, even if you haven't got the explanation about, wait a second, doors and windows, I believe that you can work with your building plan, floor plan, ceiling plan, also wall. So you have to start working as soon as possible. It's not a very hard work, but you need to start as soon as possible so that it doesn't collapse with, it doesn't make complicated with your studio work. Again, those type of things you need to consider when trying to finish assignment in architecture school. So again, you have to start as soon as possible to start drawing this one. And then it must be submitted on 16th of June. It's on Wednesday again, and then will be present. You have to present it on Thursday, 17th of June. This is the distribution of the task. There are several materials that will be given for you. So luckily, you only have one type of walls, which is clay brick. So you can use it. Just all of you will use walls, and then other will considered based on this, like doors and windows using timber and aluminum. Ceiling is the same, and roofing there will be like 2 types of materials. And this is the distribution of the tutor. And this is the same building that the previous assignment you have done in the previous assignment. So this is the basic design, but this is the building plot. So you can take a look on this one. I think that's all the explanation of the assignment. If you have any question related to the lecture or maybe the assignment, you can raise your hand. Again, I would like to suggest you take the initiative as much as possible to start have a tutorial with the tutor, because if you don't have it, then it's hard for you to finish it on time and have a good finish on your work. So is there any question related to the assignment or my lecture? You can ask now. You better ask now rather than you work and then like the previous assignment, there are some misunderstanding and stuff. So you need to ask us about the assignment. You can take a look on the assignments handout in the classroom as well, and then just give us a question related to that. Is there any question? So I got 11. Wait a minute. Novel send me to. Oh no. I got 11 students, but I think there are 2 students who submit in a total one. Yeah, I will check. So no question. Are you sure that you don't have any question related to the assignment? Again, you must do twice tutorial with your tutor. If you don't do that, then it will reduce the markings, and you didn't take a good a maximum benefit of having a tutorial one. So you don't have to be afraid of tutorial. So you should use tutorial as a learning process. If you don't have any question, maybe Pak Ngurah wants to give more information related to the assignment.
I just would like to emphasize that you have to take the assignment seriously, because this is a learning process, as underlined by Bu Fenty. So you always have an opportunity to, to review your design and have a session with your tutor and to discuss what the best, solution out of the problem that you are handling. So once again, I need to emphasize that you have to take your assignment seriously, because out of 11 students, only 9 students, successfully submitted the work. And I also noticed that maybe it's a very minor, few of small number of students do not take that seriously, even though he or she already submit the revision. So once again, take that very serious in order to get, a good mark at the end of the semester. I think that's it, Bu Fendi. Thank you very much.
Okay, thank you, Pak Ngurah. So if you have any question related to the assignment, maybe you find that today you cannot find any question, but when you are working on your assignment, then you find any difficulties or question, just directly contact your tutor and we will explain it to you. You don't have to be afraid of contacting us. I don't think that there is. I think we have agreed that during the tutorial, if you would like to use Bahasa, then we can use Bahasa. So you don't have to be afraid of using Bahasa instead of English. If you feel that English is not comfortable to be used during the tutorials, then you can use Bahasa instead. Again, we would like to, again, like what Pak Murah said, this is a very important learning process for you. You will not get any additional information about structure in the next semester. Next semester, you have one, which is more advanced. And then after that, you will not have any related lecture related to structure anymore. But in your studio, you will be asked about structure all the time until you finish the architectural school, and also until you have your own practice. So it is a very important thing, and it will be always there when you are involved in architectural projects or works, but that's why the when you are still in the basic or foundation of the course, then you can ask us whatever you think that need or important to be learned. So if you don't have any question, I think this is the end of the lecture. I will check on the feedback that I've got from the chat box throughout, because again, in this type of learning process, I'm afraid that you didn't take the lecture seriously, so that you just turn off your camera. But sometimes I know that it's not a comfortable turning on the camera all the time. That's why I want to make sure that you are following the lecture by doing the exercise. If you don't submit the exercise, then I'm sorry, I cannot give you the record for your attendance today, and it's your responsibility to do that. You are now should be independence, because you are no longer student anymore. Well, we call it student still in English, but you are no longer something that needs to be someone that needs to be said, hey, you need to do this. So you have to be more independent. Okay, I think that's all from the lecture today. Thank you, Pak Ngurah, for coming for the lecture. And I hope that you all can start the assignment as soon as possible. If you have any question, again, you can contact me or Pak Ngurah, because I have given you the access to our contact. So I hope that the next assignment will be better. And good afternoon. I will close the meeting directly. Goodbye. See you next week.
Thank you, Bu. Thank you, Pak.